And Saad, you have been working on enclosures, and you are more advanced than Jens and I am in this. You've been using 3D printing, and you've got some screenshots and demos to show us.
Yeah, absolutely. I can first start with what type of softwares you can use for 3D modeling or making enclosures or any type of mechanical part, and then I can share how I normally what my workflow is when I'm making a enclosure. So let me just quickly share my screen.
I remember the Elektor cheat cards we made, and the classic circuits that we put out every now and then. I think those are the matte black styles that we're talking about.
Okay, so normally when you're gonna be making a 3D part or any 3D printed enclosure, you will need a CAD modeling software. Now there are pretty much, I think, free softwares out there, but some of these paid ones are really good. I personally like SolidWorks because I've been using it for many years now. I also learned this was the first software I got hands on CAD modeling. You can get it out around, I think, 48 per year, so it's pretty good for makers. Other softwares you can use is Siemens. By Siemens is Solid Edge. It's free for all makers, and they have a community edition, so this is also a good software. Then I like Onshape because Onshape is pretty much based on your browser. You don't have to install it on your PC, so you can have it on anything you like, and it's also free for community. So I can have it on my laptop. I don't have to install it. Another CAD modeling software I really like is Shaper 3D, and why I like this one is because it is on iPad. And when sometimes you don't want a laptop next to you if you're somewhere out and trying to make a model to fix something or taking measurements, so this is on PC, on you can put it on iPad or Mac, and it's really good with touch screen and everything. So if you want to make simple projects, simple enclosure, this is a really good software as well.
I have a question, Saad. Is there interchangeable file format for that? So can you make a project with one of these software tools and import it in another one?
Absolutely. Normally the standard is step file. This is STEP. So you can export a step file from SolidWorks, and then it can be imported into Solid Edge or Onshape. I've been using mostly SolidWorks and Onshape, and the integration between these two they work fine. Okay. Sometimes, let's say the history, how the part was made, does not translate, but the part is there and it's editable. Other file formats are STL, but STL is not for importing and exporting parts. So normally you will use step file to export and import file formats. Okay.
And
let's move on to the next step. Yes, Brian?
I just wanted to know, I've seen a 3D modeling program called Rhino CAD. Have you ever had any experience with that?
I think it was Rhinosaurus or Rhino 3D. I've used that as well. I think that was actually the very, very first one. After that, it was SolidWorks. I think I was 7 at that time, or 8, when I got to try on that software.
Then, so 2 years ago.
Yeah, a lot.
And Jean-Francois remembers Google SketchUp. Yeah, I played with that a bit. I tried to do some, home modeling to see where to put the furniture, but I never really got into Google SketchUp.
Yeah, I don't think it's possible to do 3D printing with Google SketchUp. But I've never tried.
Got any more for us, Saad?
Yes, sure.
Sorry for the
So-
interruption.
Yep. Actually, I'm having a hard time with the windows and everything, but okay. So all right.
I think you're having a
So
clipboard there.
here is the enclosure I designed for the expansion board. Basically, when you're going to be designing any, let's say, enclosure, you're going to have a CAD model of your PCB design you made, so that you can know where the connectors are and how everything is laid out. If you have holes for mounting, you can let's suppress this. Okay. So you can know where the holes you have to mine for. Yeah. Well, let's take a step back. Before you even start a PCB, you have to be mindful about where it's going to be used and how you're going to use it. So because this board is an expansion board, so I have to take care of the connector side. So the connectors needs to be on the outside. It doesn't need to be on the top side. Or vertical connectors, horizontal work best in field conditions, because you can mark it on the top of the panel here. I can print or write something here about that connection. Then if I will have a screen, then I can put a screen here in the middle. But if I want a reset button and all that, so you can add more to your design, to your PCB, if you use horizontal connectors, which I like. So basically, you can get this step file easily from KiCad or any other PCB design software. You can export your final PCB design in step file and import it any software. And I like to use SolidWorks because it has assembly feature where I can first import the board and start making the enclosure from ground up. So first I will start from, let's say, the bottom part. And here. So first I will just make an extrude, let's say a solid body, which encloses the entire PCB. So I can know, okay, this is how it's going to cover. Then normally I use the shell command. You can also use cut, but with shell and normally in 3D printing, you should have some sort of wall thickness. If normally you're using it on the field, or it's I would say a functional 3D print, a solid wall would be about 3 millimeters. It's really good, and it gives you some sort of leverage in printing orientation. And I will get on to that later about printing orientation and everything. So then I mostly like to have fillets around my board. Then I'm going to add some holes where my PCB is going to get mounted. So sometimes you can use heated inserts inside your PCB. Let's just have a top view. Okay, so you can put a heated insert here, and you can screw your PCB like that. But sometimes if you don't want a heated insert in there, you can just, or you don't have them, then you should add some sort of cut here with a hexagon type thing. So you can add your nut here, and then you can bolt it from the top with the top side. So this is, I like to have both things, but yeah, but I prefer heated inserts. But if I don't have them, then it's nice to have a model which already has this included. So now if I use nuts, it's not going to be extruding from here. Everything that's going to be made, it's not going to be slipping off or sliding or pointing.
Do you do that yourself, or do you take ready-made things from libraries?
Well, with SolidWorks, there is a bunch of libraries you can add for nuts, fillets, and everything. I believe it's here. design library, and you can add different type of tools and assemblies and features and a lot of stuff. But mostly I don't use it if to keep things lightweight. Because sometimes if you have so many parts here with holes and features, then the CAD model gets a little bit slow on my computer. So I like to keep it simple. Mostly what I do is I measure my nut with my vernier caliper, and then I give a little bit of tolerance of, let's say, a 0.5 millimeter, which is enough. With 3D printing, normally if when you're printing, if your bed adhesion is not there, or the temperature changes, there's some sort of a deviation in measurement. So sometimes your 3D printer is a little bit smaller or a little bit bigger. So you need to have some sort of tolerance when you're designing both parts. That's why I like to design a little bit smaller enclosures and print them side by side. And another thing which is really important.
I have another question in between.
Yeah, sure.
Sorry, there are two types of 3D printers. What is best for housings? There are the traditional ones with addition.
FDM.
Yeah.
Yes, FDM is best for 3D for normal prototyping. SLS, SLA, and those resin printers, those offer really high quality. The thing about FDM printers is that it makes it layer by layer, which I will cover shortly. It has a problem of splitting. So if a part you design is under force or some sort of a tensile stress, it might split at some point, and it does not last very long. With SLS, it is a little bit more forgiving in that side. But there are so many materials out there now, I mean, with alloys and all that stuff. So this can be improved. Okay, so another thing about enclosures is, when you have your PCB, that it's nice that you can simply have your cutouts for your for your connectors. How are you going to connect them? Holes, I think it's too much. I've talked about holes now and connector placement. The most important thing which I like to have is these indentations, which really help when you're combining it with your top layer. Oh, sorry. Okay.
While you're finding that, let's take some comments here in the audience. PC Doodle says, "I still use SketchUp, tyranny of habit." And JR Ballon says, "I use EagleCAD now, part of Fusion 360." Fusion 360 comes up quite a lot, yeah. That's very neat. Saad, did you have any problem finding all of those different components in the in the libraries?
Yeah. Well, you can. I just want to stop this now, and it's not stopping.
Don't stop.
Oh, it's on the other screen. There you go. So yes, for the PCB and parts, when you're designing on KiCad, mostly you will have all these connectors in CAD model. But if you don't have them, then on SnapMagic you can download it, and then you can link it with the part you're using, and then you will have an idea how big of a part it is in real life, or on CAD at least. Yes, so I wanted to talk about these indentations between which actually encloses the part, which joins the top part with the bottom part, and it allows the top part not to slip from the bottom part. Because with 3D printing and with FDM, a little bit of let's say temperature change or anything happens, they're not actually really straight with each other. So it's nice to have these small grooves which lock themselves together, and you can basically have them little bit secure, not slipping off each other normally when it's joined together. So yeah, that's pretty much it. So let's move on to I would say when you have made your part now you have to print it, and how you want to print it I'm going to show you, which is one of the best things, or I use to make them a little bit better.
While you bring that up, comment from the Happy Ham there in Texas. He likes blue or red or black. You're in the US, it should be red, white, and blue, shouldn't it? Or maybe the yellow rose of Texas. But he does say he does a lot of radio builds and always likes boards that are not green. Back to you, Saad.
Yes. Okay, so mostly when you're be printing your enclosure, so about layering. So this is the main deal. So these are layer by layer. So they split from the top. So you need to have to be really careful when you're making these holes for mounting and everything. I like to add a little bit fillet here, 2 millimeters, dependent upon how long this mounting point is. But 3 millimeters, 2 millimeters is enough. Actually, it adds a little bit of material to the mounting point and the base part or part of the base, and then it makes it a little bit stronger. Another thing which you can do to help the part not split itself or make it a little bit more rugged is print it at a 45-degree angle. So basically, let's go a little bit back. So you can actually have it controlled like this. You can print it and change the offset of it how you like, or you can print it directly from here. And once you've done it, it will generate the supports for it. Well, some people say that don't make supports by the slicer. So this is a slicer, and it generates that G code from that CAD model, which your 3D printer will be using. I like to use my built-in support. So basically, when I'm done with a model, I will make a support for the 45-degree draft angle, which will support this part at this angle, which will help in, as you can see now, the layering is at a 45-degree angle. It's not layer by layer on top of each other. So these are the little things which you can use to make your model a little bit rugged.
Nice.
That's pretty much it.
Well, that is cool. And 20 odd years ago, 3D printing wasn't a thing. And if you wanted an enclosure, you bought something off the shelf like Jens very industriously did, or you had to get serious and go with injection molding, but then you were talking like large quantities. And question here I saw in the chat is, any tips on moving from 3D printers to injection molding? That's from PC Doodle. I don't have any experience with injection molding, but do you have any ideas, Saad?
I did made 1 or 2 parts for injection molding, and with SolidWorks, it's a little bit easy to design a mold for a part you make, and it helps you. Oh well, I'm not going to do a tutorial now, but it helps you to make some design choices to make it a better mold. Because in molding, it's actually, if I want to make this bottom part, it's going to be two mold plates I'm going to be designing. So I'm going to have to be careful with my edges, my cuts, how the part is there, the indentations, and everything needs to be really moldable. Injection molding, of course. So with this part right now, I think it can be easily be injection molded without any additions. I don't have a really good example which a part which cannot be used as injection molding, but this will be made cheaper, but this will be a little bit expensive. As you can see from the side here, these are cuts. So this will make a little bit of a problem when injection molding. because how are you going to split this part in two? Then the part of splitting comes, so you have to split the part so that when the two injection plates mold together, this needs to be, I would say, have these holes and cutouts in a proper way. This won't be able to injection molded, but this will. And to make these type of enclosures, let's say the enclosure which Jens was showing, that is injection molded. And as you can see, there were no holes on the sides of the part, and he had to drill it out by himself, because that makes the mold a little bit expensive to make, or I would say more expensive to make.